So in this session we are going to understand what is meant by stack and its implementation with the help of array. So if you observe the definition of the stack, it is just a simple thing, that is LIFO. So last in first out, you can see with the help of this diagram as well, it is saying whatever the value comes last, it will go at the first. So I hope you see in the regular life, whenever you are putting a pile of books on one another, so that is known as stack. You are placing one object on one object, one object on one object, like that you are placing a pile of object. So if you want to remove the bottommost element, first of all you need to take the topmost elements, all you need to remove, and at last you can take whatever the required thing at the bottom you want. So that's the same principle in the stacks also we will be going to follow. This is one of the data structure. So this is the linear data structure that we can be used with the help of whether we can use arrays, or we can use the dynamic arrays, or we can use the linked list. That is according to our use case. So that's see, you can read it, that follows last in first out principle. You can see with this small animation also that says here push. So inside this stack we are pushing first element A. So after this we are pushing the second element B. If you want to retrieve the element A, you want to first pop the B. Okay. And if you want to see what is the on the top of the element, that is known as peak. Peak means to see on the top of the element. So you also need another variable called top. You can see over here that this top will return the topmost element. Here the top value is 6. Basically this top is a pointer which points to the topmost element, so that we can track what is at the top and how we can remove or we can add on the top. And the last operation is we can remove the element, that is known as pop. So in this stack we are going to have mainly these main are the three operations, that is push, push, pop, peak. Okay, push, peak, pop, these three operations. And then if you see the hierarchy of the stack, where the stack in there, so inbuilt in Java. So we are going to see the inbuilt stack in Java, and we are going to also see our custom stack. Our custom stack means how we have created our custom linked list in the previous session. In a similar fashion, we are going to create the custom stack without using the Java's inbuilt. But we are going to understand the stack's hierarchy, so that is very better in the mind. So if you see clearly, stack extends, basically stack is a class which extends to vector. So vector is a class which implements the list. So basically here list is an interface which extends collection. So basically collection is the ultimate interface. You can see with the help of this diagram as well. Here the green boxes are known as the interfaces. The blue boxes are known as classes. Here you can see the stack is under at the bottommost one in the list. So here list is an interface which will not implement the functions which we can only declare there. So inside that the stack function is declared. So this is failed to implement in the collection. So collection is also an interface. So what operations that we can be performed on the stack? If you see, we have push, we have pop, we have peek, is empty, is full, size, clear. So these are the operations that we can able to perform on the stack. So I hope you know these three things that I have already explained before. That push means insert element, pop, remove, peek means to view on the top. So is empty, is full means we have to check the stack whether, let's see that also. So first of all we need to check. So suppose this is an array. If this is an array, we can have to check definitely. Is this able to accept more elements or not? Because the array is of fixed size. Remember, array is of fixed size. We need to declare the size first itself. In the linked list, that's not a problem. Okay. If you see clearly, is full, is empty, we need to check definitely. Because if there is no element, but you are trying to pop that, you are trying to remove an element, is there is no element, but so then that situation we need to create this function that is known as is empty. So or is full. If that stack is full, you are going to get stack overflow error that we need to custom message that to the user. So we have size, so we can get the size, what is the number of elements that we have in the stack, and we can clear all the elements, remove all the elements. So but majorly we are going to use these three. So yeah, you can see we can implement the stacks with the help of the linked list on arrays. I already mentioned before. So in this session we are going to understand with the arrays, because that's simple somewhat compared to the linked list. But once you understand this one, which is also somewhat if you try it, that is also easy only if you know the linked list concept. And a simple concept with the help the stack with the help of this linked list I will be saying once again. So I hope the push, the pop, the array we have seen, the linked list, this one. Okay. So basically you can see head is pointing here. We need to perform push here only, pop here. So what is meant by that? So we know in the linked list the head will be pointing to the first element, and we need to perform the push from the last and pop from the last. But here last means near the head. Understood? So now this makes some sense. You might be confused now this time. While what is this kind of situation? Why you are doing push here and pop here? Because this is the head, this is the top. Here head is known as the top. So we are doing all operations from here. This is known as bottom. So you can see, you can get clear from this image. So you need to perform the push here, the pop here, and the head is here. Because this is the most recently used element, and here the oldest element. In the linked list I am saying. In the array it is normal stack implementation. So if you read this sentence also, so perform operations push pop from the head only. Why? To get order of one complexity. This is very important. For the getting order of complexity, we are going to perform near head if you use linked list. So if you can also see the array based stack and linked list based stack. You can see the pop operation will take order of one, peek will take order of one. So space will be based on the size that we are performing, and push is also order of one. Okay, you can see it is guaranteed. It is amortized based on where we are inserting, or where we are inserting. Now currently I am in my VS Code. So currently with the help of the inbuilt stack in Java, I will be going to show you first. So if you type the stack, you will see clearly the stack is coming from java.util. If you click that, so stack will be imported. Stack will be imported from java.util, and the stack is a class. If you hover over that, you can see the stuff here. Or if you want to know more about the stack, you can control click that. If you control click that, it will be basically redirecting to class, the stack class. Inside this stack class, we can see all the methods. We have push method, means push method. We have peek method. If you come down, we have this is the method. Sorry. If you have, it will check is empty or not. Search. Okay. Yeah, basically these and all the stuff we have in the stack. Okay. We have understood. Now what I will be going to do is, basically this stack is a class. For class, what we are going to do, for the stacks, we are going to create an array. So I will name it I will name this object, okay, as nums. So I will say new, and I will say of type stack. So this is the simple syntax that I have made. You can also introduce the type safety. I am going to have only integer inside that, and you can also have the type safety here, and you can inside that with the wrapper class, you are going to say only integers I am going to accept. But you need not to mention here, because you are already mentioning here that all the elements coming inside, that is integer only. But if you mention integer or not, that is your wish. There is no problem in that, because if you don't mention the basic type inside this stack would be, we are storing inside these nums are objects. Okay. So now I will say nums dot push. We already know what is meant by push, what is meant by pop. Okay, I'm just pushing the value of 5 inside this nums. Okay, so after that I will be going to say nums dot push. Again I will be going to push let's say 40 or 70, anything, and another number also. For example, I am just 90. Okay, so after all this stuff, I will be going to print some stuff in the terminal, so that you can see what is there actually in the stack. So you can simply print the nums, this nums object you are printing. In the object you have 3 values, 5, 70, 90. So if you compile and run, so basically it is showing all the stuff warning up to here, but finally you can see it is showing 5, 70 and 90 is our output. But what is the warning here? It is showing 3 warnings. The warning is you need to definitely introduce the type safety here. So what I will be going to say is, I will be saying here inside integer. Okay, there is no warning. Now I will be definitely going to again recompile that. Now you can see the warnings has been reduced. So if I again mention the type safety here also, if I again compile and run, see there is no warnings, there is no error here, because you definitely want to mention the type safety. What is the type that I am always pushing? Integer. Make sure you always push the integer. So if you not push the integer, if you try to pass the array or string, so basically it is showing warning here only. For that purpose, you are going to mention the type safety. Okay, it is showing all the elements in this stack. Okay, in this stack called nums. So this is the inbuilt stack that is provided by the Java. And if you also see what is nums.pop also, so you don't need to pass any value, because automatically this pop will pop the topmost element. Here the topmost element is the last, that is the 35. So 35 will be popped. So I will be writing here. So in the comment, so this will be popped because you are pushing this element at the last. We already know the stack is the LIFO. So you can see we are having 5 and 70, but we did not have this 35 because it has been already popped from the stack. So you can also see what is there on the top. So nums dot, you can say peek. So this will be going to return the topmost element. The topmost element would be 70. If you print that, you can see it is wait, we are not returning and we are not storing, so I will say just print that. So I will be going to drag this up, I will be going to put here, and I will be going to remove this extra semicolon, and I will be going to again recompile and run. You can see it is returning the topmost element as 35. So why it is returning the topmost element as 35? Because so the topmost element as 35 because before here you can see we are popping here. So before popping only we are seeing what is the topmost element. So the topmost element is 35. So after popping that we are after peak, that means after seeing what is the top, we are popping that and we are printing the nums array. So what if before popping I also print that, and if I see what is the thing, I will compile and run. You can see first of all it is doing peak with the help of this statement. So after that I am seeing all the numbers which are there on the stack 5, 70, 35. So after that after pop that I am seeing 5 and 70. So this is the inbuilt stack provided by the Java. So I am not going to use that stack, so it will be remove that import also. Okay, that's fine and good. Sorry, what I will be going to do is, so the names will be same, so I will be going to remove up to here, or I will be going to show up to, so I am removing up to here. Basically this will be, I will remove this import as well. I will remove this import. Why I am removing that import, I will say because I want to make the custom stack. So if you hover over that, you will be going to have an option called quick fix. So click on that, it will be going to say you create class stack in package Java. So simply click on that, it will be going to create a file for you called stack.java. So inside that you are going to have clean this. Okay, so for your understanding I will be going to show you inside like this. I will be going to cut here, so I will be going to close this one also. So now you have a clear picture. Now we do not have a function called push. So basically inside this tag, so what I will be going to do is I will be going to say, so void push, I will be going to create a function called while push. It will be going to accept a data. Okay, you can see the error has been vanished because we are dealing now in the same package, demo.java and stack.java. So I will make this class will as public because both are interlinked. From this only we are going from here in the demo we are going to call the stuff. So I already mentioned there are two types to create your own stack. First of all, with the help of the array. So basically in the outside I am having a variable called array. So inside this array I am going to store the file elements. So that's the default, that is your wish. So I am also going to have another variable called top. So I will just initialize that, and I am going to have just the size. Okay, these are the three variables that I am going to use in my stack, my own build stack. So inside this push, so what you can do is, so before that what you can do is you can create a constructor. Whenever you create a object, that this constructor will be called. So you can say public, so constructor name would be stack. Okay, so inside this constructor you can mention the size would be same as the array dot length. So that would be size would be 5. So after that what you will be going to do is you are going to have the default top as is equals to -1. So I am going to initialize the top with the -1. Why? If you come here, if you come to my slides, so inside the slides you can see clearly. So before pushing anything, so there is nothing in this tag. So what you can declare there, what you can see, or what you can pick, that what you can pop. So for that reason only we are going to initialize the top, this top variable, to the bottom. So by default the array indexing starts with 0. You are not going to have the index 0. So you are going to say the top as -1. So in the top we have -1. So after that what I am going to do is I will be going to say, so void push function. Inside this we are accepting some data. So as we have already have the top, so we can simply say top plus plus. Okay, after doing top plus plus you can have one condition, that is if. So you have a statement, if statement. Inside that you are checking the top and size. If the top is greater than, if the top is greater than -1, you can see here it is nothing, means it is initialized with 0. Here top is -1, but the top is initialized here to the 0 because -1 plus 1 is 0. So the top is greater than equal to size. Yeah, in this case it is true because the top is 0 here, the size is also 0 by default. Now inside the statement you are going to say we have an array called array. So inside that you are going to say the top. So we are going to say allocate the data of the data, that what we are accepting here. So don't forget to place the semicolon. So this is the thing that we are going to have here. If you fail, so if this condition fails, if the top is that, so then inside this you can just simply say print something in the terminal, that is stack overflow. So the next we can call the public. So we can create a function called show stack. So what this function will do, basically this function will be showing all the stuff, what are the all elements in there in the stack. So basically we can call this function so with the help of the nums object. So nums dot show stack. So inside that we are not going to accept anything. So like this, in this like this situation, you are going to pass the stuff, you are going to call this method here. So inside this, what you are going to do is you are going to have a for loop. So inside that, it's not normal for loop, it's for each loop. So inside the array we are going to able to traverse that. So inside this you just print the n value that we are giving here, and you can also append with some spaces so that it will look nice in the terminal. Okay, if you see inside push only we are declaring this method. So simply from here to here you can take out that. So in the outside you can paste that method, so it's not illegal now. So I have just made a small issue that, so I'm declared this method inside this only. So make sure that you are declaring in the class. So in the stack class you need to declare, not in the push one. So you basically are able to see what is the values in the show stack. So here we have make a small mistake, that is top which is less than or equal to size minus 1, because here you can see here the size is where initialized is 0. So but first of all we are make sure that size should be -1, then top we need to compile in this fashion, and after compiling you can see it is showing the correct result. So 5 and 20 and all remaining 3 would be initialized with 0. So you can see the push, we are pushing 2 elements, that is 20, and we are having the function called show stack. So with the help of the show stack we are printing all the stuff in the terminal. Now what I am going to do is, I hope you understood the fashion. So inside the stack class we are having functions called push function, we are having function called show stack. So similarly we can have the function called peek function, we can have a function called for the pop. So for the I hope you understood the pattern, that how I am doing. So these are the three stuffs I am having, two stuff. So I hope you know the push, it will be going to push all the elements to the stack. So I hope you know what is meant by show stack. It will be printing all the stuff in the terminal. And then next we have the pop operation. So this pop operation will pop the elements. So you can see, I will explain. So in pop, so it will not accept any argument, because just popping the elements, no need of any checking. So here we are checking if top is equals to -1, means is there any element in the top is equals to -1, is there any element. If this is the case, we should say stack underflow, there is no element in the stack, we should simply return -1. Or you can simply say if there is any element, you can simply say array of top minus minus. First of all it will return the element, it will return the popping element. In this case it will pop the 5. If you here if you system.println, I hope this makes some sense now. See, you are calling nums.pop, it will be going to call this function. Inside this we are printing that stuff. What is it returning? So as the last in first out, the stack is the last in first out, it will be going to pop this 20 and it will be going to return you 20, and we are printing that 20 here. Okay, let me compile and run. So you can see we have 20. So you can see clearly we have 25, and finally it is also printing the 20. Why it is again printing 20? Because this is the first one we are printing is the pop element. If you want to confirm, just I will be going to reverse that, and if I again recompile that, so you can see first of all 5, 20, these two are printing because of this this statement show stack, because it will be going to show all the stack elements, and next we are calling this nums.pop inside here. So due to that it is at the last rate we are printing 20. And what is this peek operation? We already seen peek means to see the topmost element. If top is equals to -1, that's the case, then say that stack is empty, and return -1. Otherwise just return the top, that's it. Means we are seeing top, that's it, right? So if you want to see what's the top, so after popping this element you can simply you can call here with the help of this thing. So inside it you can call nums.pop, or nums.peek, because we already did the pop operation. So if you compile and run, you are going to say 520 because of this show function, and pop because of this returning element 20, and peek what is now current top, that is 5, that is printing successfully in the terminal. So I hope you understood stack implementation with the help of the array. Now we are going to understand the stack implementation with the help of the linked list. So in the previous sessions we have already discussed about linked list. So as the same as the linked list, as same as the stack, so mix both of them, you are going to get the implementation of stack with the help of the linked list. So there is nothing complicated, I will just explain what I did here. So you just need to have another class here for the node to create each and every node. So we have data and the next pointer in the node. So after that I am creating a constructor here. So inside that we have int data. So we are by default value passing here whenever we create a node. So by default pointer will be, the next pointer will be of type that is null. So whatever the stuff happening here inside the stack class, so the stack class we are able to successfully call from here. So inside this stack class we are introducing the type safety also, there is no issue in that. So if inside that we are having a top pointer. We already discussed in the linked list that we should have a head pointer. In the similar way, in the global level of this class, we are going to declare a variable called top of type node. Okay, the type node. Here you can see node. So after that you are going to have a constructor. Whenever you create a new object of the type node, you are going to call the stack and you are going to initialize the top with the null. So after that I'm going to push the values with the help of this code. So if you see clearly, we have public void, the same as the functions that I have created before, but it's with a small change as they are implementing here with the help of linked list. So you can see we are creating a new node. Here we are creating a new node. Okay, you can see clearly here we are creating a new node. Whenever you create a new node, this constructor will be called and the next pointer will be initialized with the null. Okay, so after creating a new node of object, or after creating a new object of the variable called new node, so inside that we are going to assign the top. So after that what we are going to do, we are going to assign the top to new node. Okay, if you see in the presentation, that is very important, we are assigning this, here head is known as the top. So whatever we are doing, we are going to push all the values to the bottom. Okay, so first of all we need to push from here. We are creating a function for pushing, right? So to push, for what we are going to say is top dot next is equals to, if you see in the code, the top, we are placing the top in the new node dot next. So we are placing this top at, this is known as new node dot next. Okay, and whenever you come across the next suppose this the top at this position, then we are going to apply the push operation in this side. So what is meant by that? Basically this next will point this side backward. So this makes some sense now, right? So you can place the top value with the help of the new node and we can print the data whatever is there in whatever we have pushed the data. If you see the direct code, you might not understand. Try to see this with the help of the diagrams so that you can understand. Okay, I already explained before, the push and pop operations will be happen with the in the side of the top side only, in the head side only. So in this I am going to display all the stuff with the help of the top pointer only. So you can say I am creating a temp pointer with the help of the temp pointer. I am going to, with the help of while loop, I am traversing all the linked list. I am printing all the stuff with the help of this temp pointer. Okay, I am in this demo.java, I am just pushing 5 and 20 and I am seeing all the values. You can see, so it says 5 is pushed and 20 is pushed, and you can see the values because we have called here nums.show. We can also have the pop operation, the peak operation also. I will also show that now. So as you can see, these are the two operations, that is one is pop operation and one is peak operation. In the pop operation, what these are that much important, so that's why I'm just quickly writing the code and explaining to you. So if you see the pop operation, we are just comparing the top with the null. So after that you just printing the stack overflow, because if top is null there is no element in that, right? So the return -1. If there is value, just come out of this and you are going to have value. So you are going to store, because the return type is integer, and suppose suppose if I say come here, so I can simply say the system.println in this, so I can call nums.pop. So basically this pop will return an element, and thus we are with the help of this object we are printing that element. Okay, so yeah, we will see that. Before that, what I will be going to explain this code. So we are storing this value inside this, and finally we are returning that value. So what is meant by this peak operation? It will be going to show. So we are seeing, is the top is equals to null? If that's the case, then we are going to say the stack is empty and return -1, because here also the return type is integer. And finally we are returning the top data, because we are returning the type safety also we are introduced, that is integer. Okay, so now what I said is, here we are seeing with the help of we are printing the pop element. Here we are seeing the topmost element with the help of this peak function, because we already make the peak and pop operations with the help of the linked list. Now if I compile and run, here you can see clearly, so 5 is pushed first and 20 is pushed, then we are seeing the operations with the help of this store stack, and finally we are having the 20 and 5. Here 20 represents the peaked value, popped value. You can see, if you want you can also append with the, and in this fashion also you can copy here and you can paste peaked element, peaked. So in this fashion, if you compile and run, you can see with the clear text also what is the popped element, that is 20, and what is the peak element. So in this fashion, how you implement with the help the stacks, with the help of the linked list, and also you have understood with the help of the arrays as well. So try to understand this code. So I hope you understood how to implement the stacks with the help of arrays and queues. So thanks for watching up to now.